Thank you very much.
So 5, 7 is inequalities for two triangles. Okay? And this is got foundation in regards to triangle equalities or congruencies. Okay? If we understand how triangles are congruent by side, 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 and side, angle, side, this allows us to make an argument about triangles being unequal. Okay? So kind of give you we'll start with the side, angle, side inequality. Okay, so I got this picture right here. All right, so side, angle, side. Would you agree that the blue sides are congruent? Would you agree that the red sides are congruent? Would you agree that the angles between, the included angles, alpha and beta there, they are congruent as well? And you see down there at the bottom, I've made them both 45, right? So those two triangles are congruent by side, angle, side, right? Okay. Now, if they're congruent by side, angle, side, then CPCTC tells you that the green segment BC would be the same as the purple segment EF, right? Okay. So we can make that conclusion. We understand that when the shapes are congruent, we have equality amongst those two things there. Okay. Now, let's talk about what happens when I make this angle go to 40. Okay, so when I hit enter, watch what that green segment does. It got what?
Shorter.
It got shorter. Okay, so now you see that when alpha, or that angle, that included angle, is less than beta, this included angle, okay, that angle right there and that angle right there are different in regards to that one being smaller. Okay, so that one's smaller. So that tells me that this side here, how does side CB compare to side EF? They're different, aren't they? But they're going to be different in the manner that these angles were different. Angle A was less than angle B, right? Or alpha and beta. Alpha was less than beta. So then this side here is less than that side. Okay? That's referred to as the side, let's write down here, side, angle, side, inequality. Okay? And with the side, angle, side inequality, the way this is set up is that that side is going to be congruent. Okay, so we got side congruent to a side. So the blue side congruent to the blue side. Then we have another set of sides that are congruent. So the red side congruent to the red side. But now the included angle, the A that's in the middle, they are unequal. Okay? But the way that you make a conclusion, or the conclusion that you can make, is about the remaining side of the triangle, okay, the third side that you haven't talked about, but the third sides are unequal in the same fashion that the angles were unequal. Okay, so if alpha is smaller and beta is bigger, okay, then the side opposite alpha is going to be the smaller side in comparison to the side that's opposite beta. So this is going to be a bigger side here. Does that kind of make sense? Okay. And you're seeing there that, BC is less than EF. All right. And if I ask it to show, I think I can show the labels here. We see that when alpha is a smaller value, this distance of 1.94 is a smaller value than that 2.15. Okay? And then if I make this one 50, alpha would be bigger than beta, right? So this side here is going to become bigger than what? This number is going to be bigger than 2.15, isn't it? So I hit enter, and we do see that number is bigger than 2.15. Okay? So that's the side, angle, side inequality. Sometimes textbooks call this instead of the side, angle, side inequality, sometimes they call it the hinge theorem. Okay, you guys know what hinges are, right? Hinges on doors or whatever. Okay. If I think about, this being, let's say, if you've ever seen a hinge, like taking a hinge off a door and putting it in your hands, this would be a side of the hinge This is a side of the hinge, and this is the pivot that hinge pivots on, right? That's what allows it to open up and close. The larger the gap between the sides of the hinge, so the larger that angle, the larger that span, then that distance is bigger, right? Okay, that distance starts to close and shorten when the angle gets smaller. All right, you can think about it as kind of, think about scissors, the hinge of scissors. Let's see here. Okay, that's all scissors are, right? Is a pivot point here. You got a hinge here. Okay, well, the distance between the tips of my scissor here, because that angle is 35 degrees, is smaller than the distance between the tips of my scissor here, because that's 40 degrees, right? Okay, so a lot of times called the hinge theorem. And of course, exam, I don't know what they're going to call it. I'm probably leaning towards them calling it the hinge theorem if they ask you about it. So that's something to think about. All right, so I want to do an example of this. Okay. So this is an example of the side angle side inequality, or the hinge theorem. If I look at those two triangles, okay, you've got a lot of things that are congruent, right? You've got some sides that are congruent. Now let's just focus on that triangle on the top. What kind of triangle up top is that? How many sides do you have congruent up there? All three, right? So that classifies that as a equilateral triangle. And if it's equilateral, it's also what? Okay, so it's fine. Talk about the angles, though. If it's equilateral, then with the angles, it's 60. Okay, equal angular, which means they're all 60. Okay, so we look at this, and the question is, if we're going to use side angle side, we need to know an angle up here. They're hiding that angle with some prerequisite information. We know the angle here is 60. Okay. Now, likewise, if all three of these sides are the same, are all of them x plus 5? Okay. So I'm going to put x plus 5 right there. You might have to, jockey around distances here in order to make a correct argument, but using all properties that we've talked about in the past. Now, we also have, 3x minus 7 there, correct? So look at these two triangles. Do you have information? When I say information, I'm talking about what is the orientation of parts that you know about. Do you have a side congruent to a side up there? You have then an angle comes right after that. Congruent, or not congruent, but unequal to another angle. And then finish that off, you have another side congruent to another side. So would you guys agree, if I put the markings on here, that side is congruent to that side? This angle, I have information about it compared to that angle. Not congruent, they're different, that's fine. And then we have this side congruent to that side. Is that doable? So do you see the side angle side relationship or orientation of parts? So we know we're going to use side angle side here. That's the inequality theorem that's going to be used. Now the question is, which angle is bigger? Which angle is bigger up there?
The top one.
Well, it's 60, right? Really hoping that wasn't a hard question. Okay, so this is a bigger angle than 45, correct? Okay, so if that's the bigger angle, which side is bigger? X plus 5 or 3x minus 7? X plus 5. So this is the bigger one. Okay, this is the smaller angle, so this is the smaller side. Okay, now what we like to do is, now that we know that x plus 5 is bigger than 3x minus 7, or vice versa, 3x minus 7 is smaller than x plus 5, we like to write the inequality. We like to be able to do some algebra here. Provide ourselves with some information in regards to what x could potentially be. If I say x plus 5, that is bigger, so greater than, right? 3x minus 7. So there we develop what we call a linear inequality. Linear meaning just if I were to graph the left-hand side and graph the right-hand side, they both provide just lines in the two-dimensional plane. Okay? And really what we're trying to figure out here is, where in the two-dimensional plane is the x plus 5 line above the 3x minus 7 line? Okay? But when graphing these things, you guys find the solution graphing them. But last year you spent quite a bit of time dealing with linear inequalities. And if you remember, you solve them just like equations, don't you? Okay. Now this is only working when exponents are 1. Okay, so x to the first in both situations. You can solve these just like normal multi-step equations. You guys remember the one kind of intricacy that is different, the one property that you have to pay attention to with inequalities? If you multiply by, you're going to tell me? If you multiply by a negative, what do you have to do with your symbol? You have to flip its direction. Okay? So at any time, if I multiply by a negative, which if I say multiply by a negative, that also means divide by a negative. Okay? Because dividing is just multiplying by a reciprocal. So whether you multiply or divide by a negative number, your inequality symbol has to change the direction it's pointing. Okay? Or maybe if you're a person that views it in the direction that it's opening up. Okay? You have to flip-flop it. Maybe on Monday, if we have a little bit more time, I'll walk you through the algebraic proof of why you have to do that. Okay? It's really not that hard to recognize why you need to flip those inequality symbols. But we can just solve this like an equation. Okay? So I'm going to, just to eliminate the hassle of having to flip the inequality sign, I'm always going to try to subtract my x's so that I'm always left with a positive number on one side. So I can subtract x from both sides, or I can subtract 3x from both sides, right? If I subtract 3x from both sides, it's going to be a negative 2x over here. And then I'll have to divide at some point by a negative to solve for positive x, right? So if I can move the x over, it makes things a little bit easier. So get 2x minus 7. I'm going to have 5 here. Add 7 to both sides. So you get 12 is greater than 2x. And then we can divide both sides by 2. And now x is less than 6. Okay, so I write it that way. Now, most of you might be comfortable reading that left to right. So if we read that left to right, we say 6 is greater than x, right? Some x value is your unknown. You don't know what x is. But right now, we know that it's at least, I don't want to say at least, it's less than 6, isn't it? Okay? If 6 is greater than x, if 6 is a number bigger than your unknown value, then your unknown value cannot be 6, right? It's got to be something smaller than 6. Okay? I think some people struggle looking at the inequality that way. If you want to flip it, flip it. There's nothing wrong with saying, I'm going to take this x and write it first. I'm going to take my 6 and write it second. Okay? But the idea that this inequality symbol has to either be pointing to x. I like to think about it as, your inequality symbol kind of being like the head of an arrow, right? Does that kind of make sense? And it's pointing to x. Okay? Well, then when I flip things, it's still got to be pointing to x. Okay? So that says x is less than 6. And I think a lot of people are more comfortable looking at it that way. X is a number that is less than 6. Is that doable? Okay. Now, you have just used the hinge theorem then to figure out potential values for x. But here's the problem. What kind of numbers could be less than 6? Give me a number that's less than 6.
5.
Okay, 5. Put 5. Okay? And we should be able to recognize the relationship that we set up. If I plug 5 in, this gives me 10 up here, right? And it gives me 15 minus 7, which would give me 8. Okay? Didn't we say that this side here, the red side, should be bigger than the smaller side? Okay? So 5 validates that. It proves that. Okay? And even if I were to use like, 5.999999, is that less than 6? Yeah. And if I would plug that 5.9999 in up here, and then plug it in down here, I will still get the true statement that the red one is bigger than the green one. Okay? We just got to go out to a lot of decimal places before we can kind of make sure that relationship exists. But what I want you to understand is that 5 is not the first value that is less than 6. Okay? Well, give me another one. Give me another number that's less than 6.
3.
Okay, 3. So if I plug in 3 up there, I would get 8 here, right? And you're going to get what here? 2. Is 8 bigger than 2? Yep. Give me another one.
1.
Okay, 1. I plug 1 and I get 6, right?
Yeah.
Okay. Plug 1 in here, what do I get?
-4.
-4. Is 6 bigger than -4?
Yeah.
You bet. What's the problem with -4?
Negative number.
Negative number. So when I use x to be 1, okay, we have an issue. And 1 might not be the first place that I see the issue. There might be other values that provide the same problem. If I let x be 1, I end up with a negative distance, basically meaning that that bottom triangle would not really exist. All right? So we have to address that. Okay? What does, and this is the way you address it. You basically look at your picture. Okay? And you pull out the expressions that exist in your picture, and you think about x plus 5. And x plus 5 is one of my expressions. What does x plus 5 represent for my picture? Is it a side or is it an angle? It's a side, right? And so x plus 5 is the length of that side, right? So lengths of sides always have to be what kind of numbers? We just talked about it, why this couldn't be -4, right? It has to be positive, okay? Well, let's say that x plus 5 has to be positive is simply saying that x plus 5 has to be bigger than 0, right? That will force x plus 5 to be a positive number. Well, the same thing then holds true. We'll go ahead and solve that in a minute. But 3x minus 7.
That's bigger than 3.
Careful.
3.999.
I know what you're trying to give me the x value, right? But let's just say that 3x minus 7 has to be bigger than 0 as well, right? Is that okay with everybody? Now you've got some work to do to kind of find that bottom value that x is allowed to be. We know it's got to be less than 6. That is going to be part of our answer. But we have seen and we've shown that if we go far enough below 6, that we start to contradict some geometry concepts that we're not allowed to do. Okay? So we go through and we solve these two inequalities. So solving this one shouldn't be too bad. X is going to be greater than -5, right? And then I solve this one. It gives me 3x is greater than 7. And then x is greater than 7/3, right? 7/3 is 2 1/3. Okay? So now, when we write inequalities, okay, we're basically saying here that x has got to be less than 6, and x has got to be greater than -5, and x has got to be greater than 7/3. All right? But we want to say that only using two numbers. Okay? We have to decide, we have to think about, let's say x is greater than -5. Give me a number relatively close to -5.
-4.
Okay, -4. So we're saying x has got to be greater than -4. And if x is greater than -4, do you have an okay distance right here?
Yes.
Yes. Do you have an okay distance here?
No.
No. Okay? So even though the algebra showed us that x had to be greater than -5, we see that with some of those values, -5 doesn't, or x being greater than -5 is not kicking out all the values that we want to kick out. So what that tells us, and I'll give you a better way of deciding this here in a moment, but that inequality is not going to be used. We do know x has to be greater than -5, but it's not as restrictive as it needs to be. When I kick that one out, all I'm left with is a 7/3 one, so that one's got to be the one I use. Okay? So x is greater than 7/3, and x is less than 6. Well, if I think about that, x is greater than 7/3 and x is less than 6. You guys remember from last year, if we were asked to graph inequalities, x is greater than 7/3. So let's say, let's put 0 down here. 7/3 is 2 1/3, so maybe it shows up there. And 6 would be over here, correct? When I say x is greater than 7/3, you guys remember drawing a picture kind of like that maybe? And then you also said that x is less than 6. You drew a picture like that. Now the question is that x has to be a number that is greater than 7/3 and it's less than 6. So graphically or visually, Doesn't that tell you that x has to be the numbers in which the graphs overlap there? Okay. So the way we write that is that they start overlapping at 7/3 and 6. So we're going to write 7/3 is less than x is less than 6. Okay? And if we look at this and we think about that notation, it should produce the exact same statements that we had up here. X is greater than 7/3, right? Does this say the same thing? If you read that from the inside out, is x greater than 7/3? Okay. And, now we don't write the word and in here, but looking at, that's terrible. Let's use blue. This says x is less than 6, right? Does this phrase right here say x is less than 6? Okay. So, that statement, 7/3 is less than x is less than 6, is the set of values that when you plug them in to your picture, you do two things. You provide positive distances, and you maintain the relationship that, if we go back up to the picture, I think it was the red segment will always be bigger than the green segment. And both those numbers will be positive. Is that okay with everyone? Couple ways of maybe deciding, because these were, we had to choose which one of these inequalities we wanted to use. Okay? Another way of doing that, other than the kind of trial and error of picking values and plugging them in, is to graph. We had x is greater than -5, and we also had x is greater than 7/3. We graph them both together on a number line. So maybe -5 is there. 7/3 is to the right of it, right? Okay. X is greater than -5. So it'd be those values there. And that, we have to write it this way because that incorporates an infinite number of values, right? And you can't logistically write all those answers down. You would die doing that. Okay. And then I have x is greater than 7/3. I have those infinite number of values. When we want to choose, when we have to choose, we have a decision to be made about which one of those inequalities to start a problem off with. We choose the one that is most restrictive. Okay? And if you think about what restrictive means, it means you're limited, right? Okay, if you think about like your parents, you might have a parent that's kind of lenient, but you then also have a parent that's a little bit more restrictive, right? Okay? If I would have asked my mom when I was in high school, can I have the car? She would have said, yeah. If I would have asked my dad, he said, no, walk. Okay? My dad was more restrictive, like he limited me more. Okay? Which one of those graphs is limiting itself or providing a larger limit of values than the other one? Would you think about the top one? The top one has infinite number of solutions in it, right? There's a lot of things in there. Does the bottom one also have an infinite number of solutions? But which one has more? Doesn't the top one have more? Doesn't the top one have all these values in here that are extra? So do you see that this one, in regards to the amount of solutions we have, that one is the one that's limiting? That one's the one that's most restrictive? So that's the one we choose. Okay? If you want to view it as we choose the one where they start overlapping, that would be fine as well. Okay? The idea of choosing where they start overlapping means that, like a value of 3 is over here. If I choose x to be 3, okay, that means when I plug it in to the expression that provided this inequality here, it means I will get a positive number back. So plug in 3 here, you get 2 back, right? Is that a positive number? Okay. If I take that 3 and plug it into the expression that gave me this graph, plug 3 in to there, do you get a positive number back? Yeah. Okay. And that's what we want, right? We want both those distances to be positive. So we start plugging it in where they overlap. If I were just pick a number right here, like 0, okay, plug 0 in, does it give me a negative number right there? Yeah. And that's why for this inequality down here, we didn't have it graphed. So it would provide me a negative number plugged into that expression, but it would give me a positive number there, right? So it's okay for that one, but it's not okay for this one. So that's why we don't choose any of those values, because they're not overlapping. And if I chose a number over here, like -5, or sorry, -6, -5.5, whatever, you would plug that in, and you would get a negative number here, but you would also get a negative number here. Does that make sense, everyone? Okay. An additional thing you could do to get the entire inequality is you could actually put the inequality that you came up with in using the theorem, and it said x is less than 6, right? It's a terrible line, but where do those three start overlapping? Don't they start overlapping right here at 7/3 and finish all three overlapping right there at 6? Is that range of values exactly the same thing that this says? All right. And I think, some of you are going to be able to do this without a graph. Okay? Some of you are going to need a graph. My suggestion, if you know you're struggling with this, you're struggling coming up with the right answers, which inequalities to choose, draw the picture, draw the graph. It makes your life so much easier with that decision. And we're always looking for where everything starts to overlap. Okay? When dealing with inequalities, and this is not just for this class, this is for every class that you take beyond this that asks you inequality questions, and you're going to have a lot of classes that do that. Pretty much every math class beyond this point at some stage will deal with inequalities. Let's say that I have x, we just said x to be greater than 7/3, right? Okay, so that would be, if I was shading my number line, 7/3 is 2.33333 repeating forever, correct? So they're showing that where that blue dotted line is and then shading to the right, those are all your infinite solutions. Is that okay? Well, if I take that 7/3 and I want to round it, because I don't like dealing with fractions, if I write this as x is greater than 2.3, and I'll just go 2.33. And it really doesn't matter how many decimal places I go over, this relationship's going to exist. I get that. Okay, now I'm going to change the color so we can make a distinction here. Change it to red. It looks like it gave me the same values, right? Okay. But we're going to do something here and kind of realize that 2.333333 is a bigger number than 2.33. Would you agree with that? Okay. More decimal places, more values, it's a larger number. So these two things should not be the same. Okay? And if I zoom in here on 2.3, you start to see that there is a gap, right? Okay? So what we've done, when we take a fraction and we rewrite it as a decimal, and we've rounded things off, in this case we made the 7/3 actually smaller than what it was, or what it should be. And we say that x has to be bigger than 2.33. We actually include more values in our solution than it really should be in our solution. And right there, I've actually included, does anybody know how many values are in that little red section right there? Take a guess.
1 million.
Infinite. Okay? Because I can keep zooming in, and I can keep finding more and more values, right? Does that kind of make sense? All right? So when you take an inequality that has fractional components, and you rewrite those fractions and round them, you have now completely messed up your inequality. You've included or excluded an infinite number of solutions that you really should have in your answers. Okay? And that's a problem. Okay? You talked about inequalities last year, including one value. If I have an infinite number of solutions and I've got those infinite numbers accurate, and I include one extra one that shouldn't be in there, even though I've got an infinite number of solutions that are right, I've got one solution that is wrong and one bad solution messes them all up. It says they're all wrong. Does that make sense? And the same idea. If I have an infinite number of solutions, but I leave one out that should be in there, then I'm still wrong. Okay? So those things are some algebraic concepts that we need to maybe rely on or pay attention to from last year. All right, so that's like I said, that's the side angle side. Let's deal with side. This one is usually one that I think many people are maybe a little more comfortable with. If I look at those two triangles, this is a side inequality. If I look at those two triangles, would you guys agree that if I've got the blue congruent to the blue, the red congruent to the red, and then the third side, the green and the purple, right now they're both set at 2.6, right? Mm-hmm. So those two triangles are congruent by side, right? So if those are congruent by side, what is the argument that you can make about the green angle A and the purple angle D?
They're equal.
They're equal. They're the same. They're congruent, right? CPCTC says those two things are the same when the triangles are the same, right? Well, let's make the triangles not the same. Let's make this 2.6. Let's make that side there get bigger. What just happened to that angle?
Got bigger.
It got bigger. Okay, did this angle over here change?
Nope.
No. So this angle, so if I look at these sides, I don't know if I can put all these distances in. Okay, so if I look at all those sides, we see 2.53, 2.53, and now we see 3.6 and 2.6, right? We have information about all three sides. And we know that this side is bigger than that side, right? That's smaller. So what does that tell me about that angle compared to angle D?
It's bigger.
Yeah, measure of angle A has got to be bigger than measure of angle D. And that is referred to as the side inequality. Okay? The side inequality is going to allow you to make a comparison about angles. Okay? So let's do an example of that one. This example is a little bit easier than what we just did, just because of the parts that they give us. In a lot of these inequality questions, just because of the amount of information that we currently know, those additional inequalities that we make that we want to make sure that we don't violate any geometry concepts, like making the distances positive. We want to make angles positive as well. We can get in a lot more detail than just that. We can go a lot further based off the information they give me. Okay, and we'll kind of talk about that maybe when we wrap this question up. Looking at this information, would you guys agree that what I always like to do is I know that side is going to allow me to compare angles, and side is going to allow me to compare sides. So what I always do is I look at the expressions. I look at 7x plus 4, and that's dealing with an angle, right? So I want to probably compare some angles here. So I just want to verify that I have sides that are congruent. So I verify that I have the side inequality existing here. So would you agree that 6 is congruent to 6?
Yeah.
Would you agree that 7 is congruent to 7?
Yeah.
All right. Now the third side, the sides that are unequal, okay, because in side, again, that side and side are going to be congruent. That side and respective side are congruent. These are going to be incongruent. These are unequal. So would you agree that these third sides are unequal?
Yeah.
Which one's bigger?
The left one.
Okay, so 12 is bigger, right? So what's that tell me about the angle opposite 12 compared to the angle opposite 8? What am I going to say about 140 compared to 7x plus 4?
140 is greater.
140 is greater. Okay. Does that make sense, everyone? Okay, so let's go through and solve this. Subtract 4 from both sides. So 136 is greater than 7x. Divide both sides by 7. It's that. Okay. Now that's about 19. I think it's about 19.52 or something like that. I'm going to leave it. It's not a nice frac or a decimal. So I'm going to leave this as x is less than 136 over 7 because I don't want to get in a situation of having to round something and then maybe including too many values or excluding too many values. So I leave it as 136 over 7. Does that make sense, everyone? Okay. And if I leave it that way, it's less work, right? I don't have to grab my calculator and evaluate it. I do the work by hand and I'm done. We should probably simplify if we can. 7's a prime number, so all I have to do is see if 136 is divisible by 7, and it's not. Okay? So 136 over 7 is fully reduced. So that's one value of our inequality. The next thing is to look at this expression here. Because think about this. If x is negative 1, what do you get back for your angle measurement? If x is negative 1.
A negative number?
Yeah, you get negative 3 back, right? Can an angle be negative 3 degrees?
No.
No. Now, negative 1 is not the first number that does that. Okay, so we got to do some work to figure out what is that first number that provides me a negative number. So we just take the 7x plus 4, and we know it represents an angle, and we're saying it's going to be greater than 0. It's going to be a positive number. Okay. Subtract 4 from both sides. and then divide both sides by 7. So x has to be bigger than -4/7. Okay? Is that doable? Now the last one, we had other expressions that made us kind of have to make a decision on whether, I think it was choose -5, x greater than -5 or x greater than 7/3. Do we have any other extra expressions here? No, this was the only expression, right? So I don't have to make a decision. I know that one's going to be part of my answer. I know that's going to be part of my answer. Okay? We're looking for numbers that are between 1/36/7 and -4/7. So I write this as -4/7 is less than x, because that's exactly what this is saying. Okay? And then I write x is less than 136/7, because that's exactly what that's saying. And that would be my final solution. When you write these, they're called intersection statements or and statements or between statements. When you have x in the middle of your final statement, your inequalities are always going to be pointing to the left, and your numbers are always going to be in order from left to right. The left one's going to be smallest, your right one's going to be the biggest. Okay? You'll never flip-flop these two inequalities. They'll never be pointing to the right. And one will never be pointing left, and one will never be pointing right. Does that make sense? They're always in this order here. Okay? Is this something we can do? All right, now, eventually, and I'm not going to make you do this, but kind of open your eyes to, what may lie ahead in other geometry courses if you were to go to like a collegiate level course or something like that. What if they would have given me this angle here to be, let's just say 50? Okay? We know that obviously, yes, this angle has to be less than that, right? But doesn't this angle also have to be less than, doesn't 7x plus 4 have to be less than 132? Or 130 as well? Okay? So those might end up eventually being components that we would want to look at. But the reason we would look at those is because they'd have to provide us extra information. The more information they provide us, the more we can kind of narrow down and focus and zero in on the actual value of x. All right? The less information, the smaller amount of information is going to be maybe in regards to work for you a little bit more beneficial. Okay? Give the homework assignment in Math Excel a shot. We'll talk about